Welcome to the session on trigonometric ratios, areas of triangles. The objectives for this session are to find the area of a triangle using an appropriate formula. In order to prove our particular formula for the area of a triangle, we are going to need trigonometric ratios. So let's recall these. Sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. In this session, we are going to show that the area of any triangle can be found when you know two sides and the angle between them. So the area of the triangle equals half AB sine C, using the notation shown in the diagram on your screen. In the diagram, do ensure that each side has the same letter as the angle opposite. So little a is opposite capital A, little b is opposite capital B, and little c is opposite capital C. We are now going to proceed to prove that the area of a triangle is equal to half AB sine C. Consider the triangle shown. In triangle ABC, drop a perpendicular from A to BC, as shown. The height is denoted by h. We know from previous knowledge that the area of a triangle is half base times the perpendicular height. So in our triangle ABC, this equals half A times h. Now in triangle AXC, sine C is equal to h over b. This is from the formula sine theta equals opposite over hypotenuse, where sine theta equals sine C, h is the opposite, and b is the hypotenuse. Rearranging this, we have that h is equal to b sine C, as shown. And then substituting in the formula for the area of a triangle, we have that the area for triangle ABC equals half A times B sine C, which equals h. And therefore we have proved that the area for triangle ABC is equal to half AB sine C. Let's now apply this to an example. Work out the area of the triangle shown on your screen. Pause the video and have a go. Press play when you're ready to view the solution. Let's label the sides as shown first of all, and then solve. From our formula we have that the area of the triangle is equal to half AB sine C. Therefore, plugging in the values, we have that the area of a triangle equals half times A, which is 1.4 centimeters, times B, which is 7.4 centimeters, times sine 110 degrees, where 110 degrees is the angle in between these two sides. And if you plug these values into your calculator, you should get that this is 4.9 centimeters squared to 1 decimal place. Now let's take a look at another example. Find the angle x in the diagram given that the area of triangle ABC is 12 centimeters squared. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We have that the area of the triangle is half AB sine C. Therefore, plugging in the values, we have that the area of the triangle is 12 centimeters squared, which equals half times A, which is 6, times B, which is 4.5, times sine x, and we're trying to find x. Rearranging gives us that sine x equals 12 times 2, over 6 times 4.5, which equals 24 over 26. And therefore, if we inverse sine this expression, we obtain that x equals 67.4 degrees. In our next example, we are going to need the sine rule. So here's a quick reminder. The sine rule can be used to work out missing sides or angles in triangles. The following version is used to find the length of a missing angle. Sine A over A equals sine B over B equals sine C over C. And now for another example. The quadrilateral ABCD is a square. Angle CED is obtuse. Find the area of triangle CED in the diagram shown. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. In triangle CED, which has been highlighted, CD equals 10 centimeters. And angle EDC equals 90 degrees minus 40 degrees, which is 50 degrees. Using the sine rule, we can find angle CED. So sine of angle CED over 10 equals sine 50 over 8. And rearranging gives us that sine angle CED equals 0.95756. And if we inverse sine, we obtain that angle CED equals 73.2 degrees. And so angle ECD equals 180 degrees minus 50 degrees minus 73.2 degrees, because the sum of the angles in a triangle add up to 180 degrees, which of course gives us 56.8 degrees. We can now summarize this information. We have the length of two sides, which are 8 centimeters and 10 centimeters, and we have the angle in between them, which is 56.8 degrees. So we can now use our formula for the area of a triangle to find the area of triangle CED. So plugging in the values, we have that the area of a triangle equals half times 8 times 10 times sine 56.8 degrees, which equals 33.5 centimeters squared. This brings us to the end of this session. If you have understood its contents, you should be able to find the area of a triangle using an appropriate formula. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.